Welcome all. I Dr. Parveen Sheikh, Assistant Professor, Department of Physics, Dahiwadi College, Dahiwadi. Today I am going to discuss the topic sound and acoustics of building. What is acoustics? Acoustic is a branch of physics which deals with the production, transfer and reception of sound. So here, what is sound? Sound is a vibration of particles of medium. So you need a medium to propagate the sound. So depending on their frequency ranges, the sound is classified into infrasonic, audible and ultrasonic waves. Infrasonic waves are the waves whose frequency is less than 20 Hz. Audible range of sound is a frequency having a 20 Hz to 20,000 Hz, and the infrasonic waves are having the frequency greater than 20,000 Hz. So here we have to study difference between musical sound and noise. So musical sound is what? It is a pleasant sound. Suppose you take examples of different instruments, the sound created by different instruments like harmonium, violin, flute, piano, mandolin. These will produce a very pleasant sound, and here whatever are the waves are very periodic, smooth, and there is no sudden change in the loudness or amplitude. Then noise. Noise is an unwanted sound. So in the case of noise waves, we are having a very irregular shaped waves, sound waves, means there is a sudden change in the amplitude or loudness of that waves is there. So sound of aeroplane, road traffic, or if you are going to take an example of elevator, operating machines, crackers, these are unwanted sound or painful sound. So here we have to go for the different parameters which are contribute in the study of acoustics of building, because final what is our motto? Our motto is to study acoustics of building, and we should be familiar with the basic parameters which are used in the study of acoustics of building. So first parameter is the intensity and loudness of sound. So intensity of sound is nothing but the amount of energy crossing per unit area in unit time with area of the surface perpendicular to direction of propagation of sound waves. So here it is nothing but how much power is carried per unit area is nothing but your intensity. So intensity is depend on different parameters. Mathematically it is given as I is equal to 2 pi square n a square v rho. What is n? N is a frequency of sound waves, a is the amplitude of sound waves, rho is the density of medium, v is the velocity of sound. So here you need a medium particle. So depending on the velocity of sound, as velocity of sound is differ for different media. If you are having a solid medium, in case of solid medium, particles are very close to each other. So velocity of sound is very large as comparison to your liquid and gases. In case of gases, the medium particles are far away, so velocity is less in case of gases as comparison to liquid and solid. So we are going to express that intensity in terms of some units. SI unit is a watt per meter square and CGS unit is a watt per centimeter square. Next quantity is the loudness of sound. So loudness is means how much louder is that sound. It is nothing but the sensation, degree of sensation of the sound by the human ear. So it is depend on different parameters. So here we are having a different parameters which will define the loudness of sound. So it depends on amplitude, area of source and how much distance from the source. Again it is also depend on density of medium and sensitivity of ear. So it is nothing but the sensation of sound. It is a completely subjective quantity. Then we are going to express the intensity in terms of intensity level, as we are having a very wide range of intensity. As we have seen, intensity varies from 10 raised to minus 16 watt per centimeter square to 10 raised to minus 4 watt per centimeter square for minimum to maximum without pain. So here we are going to design that scale which is called as a intensity level. So intensity level is nothing but the logarithmic ratio of intensity I of a sound to the standard intensity I naught. So here intensity, standard intensity is taken as 10 raised to minus 16 watt per centimeter square. So that is nothing but a 0 decibel, or it is called as a threshold of audibility, or it is nothing but the minimum intensity that can be sensed by the human ear. Then threshold of feeling, which is a maximum intensity that can be sensed by the human ear without pain. Okay, we are having sound waves of various intensity, but the range which can be sensed by the human being without pain is from minimum 10 raised to minus 16 watt per centimeter square to maximum 10 raised to minus 4 watt per centimeter square. So this quantity is called as a threshold of feeling, and minimum is called as a threshold of audibility. So here we have here a chart of different sources of sound versus their intensity level. So here we are having few examples which will be beyond the threshold of feeling, means above the threshold of feeling, that is they are a painful sounds, means you can say the sound waves which are having a intensity level about 120 dB are called as the painful sounds, or they are above the threshold of feeling. So here we are having many examples: pneumatic drill, siren at 30 meter, loud car horn, they might be around 90-80 decibel. Then you are having some good examples of quiet room which is having the 20 dB intensity level. So here we are having a different examples which will contribute for the intensity level. So it is varying from 0 to 120 dB is a pleasant, and above that it is a painful sound. So we are having in classroom there is a whispering of the student, it may be around 60 dB. So here if you have to go for the good acoustics, we should also consider this parameter, and we have to focus on minimize this. If there is some intensity levels are more, then we have to contribute something by using some other materials. So we are having a good contribution of absorbing materials in design of good acoustics. So what are the absorbing materials? The special materials which is used to increase the absorption of sound waves and to reduce the reflection. So here whatever are the absorbing materials are necessarily to be a porous material, which can be a textile, fleece, carpets, foams, wool, cotton wool, and special acoustic plasters. They will absorb the sound energy and they will damp the sound energy or these oscillations by friction. So here it is possible to absorb the excess sound. So by using a different absorbing material, we can reduce the unnecessary noises which are created. If you take a washing machine, example of washing machine. So in case of washing machine also, when there is a cycle is going on, what will happen? We are having a excess noise or unwanted sound. So we can use there some absorbing material which is a porous and which can absorb the sound energy, and this can be damped by the friction. So here we are having various examples of absorbing materials. Then we are having we should have the knowledge of absorption coefficient. So absorption coefficient is nothing but the how much energy absorbed by the particular surface upon total energy incident on that surface. So there is one special unit is designed which is nothing but the open window. Okay, this is one of the standard unit of absorption. So why it is a open window? Because whatever is the incident